construct first the B tree of order 4, and after that I'll ask you to delete some numbers and will tell you that what will be the procedure for deletion. So has anybody prepared this B tree? If yes, then unmute yourself and tell me the structure. And if no one has done, then we have to start from here only. If anyone has prepared the tree, then unmute yourself and tell. Order 4, that means a node can have maximum 3 values. Okay, maximum 3. The moment it will become more than 3, the node has to be splitted with its mid or medium value. So first is 60. Next 70 to 75. Okay. Then the value is 45. Now it has become 4. You cannot make it 4 and you need to take any of the middle value. So either you take 60 or take 70 and then go for the next level. So let us split it. Say I'm taking 70 and up, 45, 60, this side 70. Sorry. And this will be 70. Next data is 51. So it has to be inserted here. So this will be 45, 51, 60, 45, 51, 60. Next data is 55. So this will be again 45, 51, 55, 60. So again, in this node, the number of values become 4. So again, one of the item you have to take upstairs. So let us make it. It will be, say, I'm taking 55. $55, 70, this side 75, this side 45, 51, from the middle 60. Next is 64. So that will be added here, 64. Then there will be 67. Then the elements are 77, 78, all this. So you insert here 77, 78, then 89. Again, the moment you get here the 4 elements, you need to take any of these middle element to the upper bit. Okay. So this will become 55, 70, 77, 78, 79, this side you have 75 here, then here you will get this 60, 64, 67, 45, 51. So if this is your tree, you can check now that from here 45, 51, 45, 51, then go to this side, this is 55, then this 55 is actually intermediate element of these two leaf nodes. So from the 55, again it will come to this side, 64, 67, then again it will go here, 70 is the middle element or the intermediate element of these two nodes. So after that, it will go here, then again it is coming back here, and then it will go 77, then 78, 80. So if you can move your just the arrangement, if you can check that for every leaf node or every intermediate node, if you can go upstairs, in between the nodes, you will find the intermediate value. And for every intermediate value, the left values are less than that and the right values are greater than that. Now, this is one example that starts with the even order to show that how these things will operate with those on. Now, I'll discuss the deletion. So what kind of question comes from here? Either part of the tree can be given, you need to insert the new elements and readjust, or the tree can be given and you may be asked that delete that particular element. Now, what are the rules for deletion? Rules for deletions are like this. What is the basic restriction? The basic restriction is that a node can have maximum n-1 value, but there is a minimum limit also, that is n by 2 or n by 2 minus 1, we can take it in this way. So n by 2, if it is less than minimum 2, n by 2, then you cannot delete directly. Now, say you have to delete, say 67. So the moment you will be asked that you have to delete some, so what is the job? Now you have to search that in which leaf node it belongs. Now, as you got that this is belong to this particular node, so as this node is containing 3 values, as this node is containing maximum number of values, so you can delete this easily. Now you no need to do anything further. So now it has become 55, 70, 77, 45, 51, 60, 64, 75, 78, 79. Now onwards, if I want to delete any value, things will be very much tricky. So how say or what to do? Say now you want to delete the 51. So if you observe this particular node, it has only two values, that is minimum number of values. If I delete 51, what will happen? It will happen that no, means it will become a single valued node like this after deletion or that kind of thing. That's actually not allowed. That's actually not allowed. Okay. So what you need to do now, you need to borrow. Now, from where you can borrow? Now, either from the left side node or from the right side node. If you find that left side node is having more than the minimum number of values, you can borrow. Say if 67 is not deleted, till now 67 is here, then this particular node is having at least, the right side node is having at least one extra value. That means you can borrow. Now, borrow means what? Will you will delete 51. So minimum value from here will go here, 60. And 55, the intermediate value, will come down to here. What happened? If I want to delete the value 51, which is in a leaf node, is having only two values. So the moment I will delete one value, it require that you have to do what? You have to make it, you cannot make it such thing that it will be of one single value only. You should not do it. So now if 67 is not deleted, if it is already there, in this situation, first option is borrowing from left sibling or right sibling. So here no left sibling exists, only right sibling exists, and luckily it has three values. So you can borrow from here. Now, borrowing doesn't mean that you can directly take a value and fix it here. No, borrowing involves this intermediate state. If you are borrowing from the right sibling, then minimum of right sibling will go up. Intermediate value will come to the leaf node. Then everything can be balanced. Now, if these are not the situation, if it is also have two nodes, then say you have to delete 51, but there is no position to borrow. Then what will be done? Then you delete 51. You take 55 back here and merge them. Even this 75 position is also very odd, because it's a single, it is violating the minimum. But still, as it's a leaf node and if it is occurs, you cannot help it. So if I am in this situation that I have to delete 51 in this situation, then what I need to do, I have to merge these two. But only merging, if I write 55 here and 45, 60, 64 cannot be merged, then the intermediate value will also join them. It will become 45, 55, 60, 64. Okay. Now, if you do this one, then if you are in this situation, then what you will do? Now again, this becomes 4. So again, something will go up. So let it go up. And this is as a single node. So either you merge it again with this, or this side and something. And if any case, this will again become 4, then whatever any of the middle element will go on. This is the way we do the B-tree deletions. Remember this thing. The things will be, this is the smallest side, then the intermediate value is a little bit up. The direction, whatever the operation, be it insertion or deletion, it has to maintain this movement. Fine. No, this movement, the words, these are not written anywhere. This is just your observation that you need to maintain, and rest thing is this, how many values it can have at all phase, how many children a node can have, maximum m children, minimum this, and what about the number of values. Fine. So this is the thing that you need to do. This is the thing. So if you have any query, you may ask. Otherwise, I can move to the next thing.
Can you explain the deletion once again?
ম্যাম একটু ছোট করে ব্রিফ করে দেবেন।
আচ্ছা। Whenever you want to delete, 3 cases. Leaf node is having more than minimum. Minimum means whatever the order, half of that. More than minimum, if that is the situation, then you don't need to bother, you just simply delete. Second is number of values are minimum already. Minimum number of values are there. That means if you delete, it will go below the minimum level. Then borrow from left or right sibling. Then borrow from left or right sibling. How you can borrow? Say if it is, say this side it is 1, 2, this side it is 7, 8, and here it is 5. Here it is 5, 9, 12, anything, whatever. Now, if you want to, and the order is 4. So if you need to delete this 2, what you need to do? If I delete the 2 directly, it will become single. That's not actually desirable. So what you need to do, you need to borrow. Have you anything in the left sibling? No left sibling exists, only the right sibling exists. So what you will do? Now, you need to borrow, but you cannot take the 7 directly here or 8 directly here. You cannot take it directly here. So what you can do? The intermediate value, this can come here. And if you are borrowing from the right side, then the minimum of the right sibling, the 7, that will go here. So 7 will go here, 5 will come here, and 2 will be deleted. This is the thing will occur if I borrow from the right sibling.
মিস উপরে যেটা মিনিমাম থাকবে ওটাই রিপ্লেস হবে তো।
উপরের মিনিমাম থাকবে
মানে 5, 9 পুরো
ওপরের মিনিমামে তো নয়, ইন্টারমিডিয়েট ভ্যালু বলছি তো, ইন্টারমিডিয়েট ভ্যালু, ওপরের মিনিমামের ব্যাপার নয়, ইন্টারমিডিয়েট। ইফ আই কনসিডার the structure 1 2 is this side, 7 8 is this side, so 5 is intermediate. Fine, 5 is intermediate, that's why you are taking, it's about intermediate value. If it is here 8 10 11, this one, and say the order is 5, then it has to be, or say order is that is say order is 7 or something, or order is 6, then if I delete this, that is okay. But if it is less than that, then I need to take every time, whenever, if this is your parent position, this is your left child, this is your right child, if you need to delete something from left, then it will add, it is already minimum, that is m by 2, then it need to borrow something from the left side if that exists, or from the right side, means whoever is having more number of values, it can borrow from there only. But if more values are available, the borrowing doesn't involve that it will take directly the value. Say, if it need to take it from the left side, say it is having 3 elements and the right sibling is having 2 elements, and it has only 2 elements, that's why it need to borrow. So where, from where it can borrow? In that case, it will definitely take to borrow from the left sibling. In that case, what will happen? Borrowing doesn't involve that it will go from this node to this thing. It will never happen. What will happen? Now, from the left sibling, the maximum value will go to the upper level, and intermediate value that will come to this phase. Okay. If the reverse thing occurs, then intermediate value, I'm just writing the I, that will come here, and from the right, the minimum will go here. Clear? What you need to do, that is that clear? It's not about from the parent which is minimum, it's about which one is intermediate of this value. Is it clear what you need to do exactly?
Yes, ma'am.
Yes, sir.
Okay. Now, another dangerous situation can happen when you have no space to borrow. Means the right sibling and the left sibling, both of them are of same stature. That, say, if order is 4, your left sibling and right sibling of the node from where you are supposed to delete something, every node is having only 2 values in it. Every node, say, it may happen. So if every node is, means if their situation is that you cannot borrow, if you cannot borrow, then you need to merge the nodes. Along with its intermediate value. Means what? Say Here some xy is there, here some uv is there, here some a, B, C, D, this kind of values are already there, or A, B, C. So now if I want to delete Y or the U, the situation is, or say here also you have some value, or here you have also some value, say E and A, means this is here, this is here, this is here, and so and so. So the situation is that, say you want to delete something, say E or F. Okay. So if I want to delete E or F, what will happen? If I want to delete E, I cannot borrow from left side. I cannot borrow from right side. Then I will stop deleting. No, deletion cannot be stopped. You have to delete. But you will delete it. So that means it will become single F. Then you have to merge either with this side or with that side. Now, if I merge directly X, Y, and F, you say, yes, you asked me to merge, I have merged. But is it correct? No, it's not correct. Why? Because say this X and Y, they are less than the A, and F is greater than the A. Then what will happen? This will be a wrong thing. So when you are merging, the intermediate element will come here. Intermediate element will come here. It will become this. Now again, if the orders are not maintained or anything else, any other situation, things may go up. Again, if in that situation also things are not matching, then some else can be merged and something else can be done here also. Means this becomes 4. Again, it's violating the rule. Then if you take Y back there, you may take that you take Y, then X will become alone. Then you think that, okay, then don't merge with X. Then what I can do now, if it can be merged with UV, if that can be done. Otherwise, what you can do now, otherwise, if I cannot merge it in this way, if I do it F U V. Now, if I do F U V, again that cannot be done directly. Again, it will become F B U V. Now, the situation is that it will propagate in the upstairs. So better if I can do in this way that say B will be this side, something will be this side, something will be this side, then if I can manage. So it has to be checked thoroughly that what can be done. Whether you borrow, whether you merge, you need to take care the intermediate element also. But at any time, you are not supposed to violate its rule. Same thing, if it is not a leaf node, if it is a intermediate node, means if it is an internal node other than the leaf node, then also the same thing. If deletion occurs to a situation and it leads to a situation that when it will be less than m by 2 elements, then you have to merge and rearrange the things again. Okay. Is the deletion is clear now? Is the deletion is clear?
Yes, ma'am.
Okay. You can take the examples from any book or any material and practice at least 1 or 2 insertion and deletion. Then you can understand. Or you can take random number also. Then you can practice. But if you take it from some external resource, you may get the solution there that may help you for further calculation. Okay. So next the thing that will start, that is about the graph. So as of now, what we have discussed, so the tree is a cyclic graph without any cycle. But the graph can have cycle. Graph can have cycle. Okay, fine. Now, whenever we deal with the graph, what are the things generally we do? Say traversal, say spanning tree, say shortest path. Now, approach wise, they are of different category also. But at the category maybe some of them are of greedy category. Some of them are of dynamic category. What it is? In a line, greedy means that each step you are trying to find the best possible solution. Greedy means at each step you are trying to find best possible node or best possible value. And dynamic says that you go for all possibility till the end, and at the end you will be concluding which one is the best. What I am telling, for the greedy, what happened, say here 3 paths are there. Among these 3 paths, the minimum will be chosen. And whatever the minimum has been chosen, based on that, you will go for the further thing. Again, from here, whatever the minimum, it will go for the further thing. But sometimes it happens that this particular procedure is not giving the most satisfactory result. The edges that you have left initially, if you go further, then you find that from the very beginning stage, the edge is maybe more costly, that is having more weightage, that will be less in, just a minute, let me switch off the fan. Oh, fanta off kore dao to, কি ঠান্ডা লাগছে।
আমাদের ফেভিস্টিক চাই, তো আমার কেউ বুঝতেই পারছি না। সব এক্সাম হলে তিনি নিচে চলে গেছেন, খুলতে গেছিলাম ওখানে গিয়ে চাইলে তো
Okay. So the point is that in case of greedy approach, what may happen that the road path that you have chosen at the beginning, after certain state, it's not giving you satisfactory result. But you cannot go back and start again. That is the drawback of the greedy approach. May not give you the full satisfactory result. But in case of dynamic, we go for all kinds of, we go for all possible routes at each step, and at the end the conclusion is being taken that which is the most satisfactory, that is decided at the end only. Okay. So first we will do the traversal.
Ma'am,
Yes.
ম্যাম সাইক্লিক অ্যাসাইক্লিক ব্যাপারটা একটু ছোট করে বলবে?
কি?
মিস আপনি বলেন না ট্রি ইজ অ্যাসাইক্লিক গ্রাফ,
হ্যাঁ।
ওই জায়গাটা একটু ছোট করে বলুন।
ও আচ্ছা। This is tree because this is not closed. Once it is closed, it's from the cycle. So if a graph is having closed environment, that is cycle, that is cyclic graph. If it is not having any cycle, means it's not closed, then it is acyclic. Okay. Cyclic means it is containing some cycle, and acyclic means it does not contain cycle.
আচ্ছা আচ্ছা।
A graph can be represented. Before we proceed, we need to know one thing, that is how a graph can be represented in the memory. We use array format and English format because we do not have any other way. They are called adjacency matrix and adjacency list. What is the meaning of adjacency? Now, who is connected to whom? So say if you have one graph, If this is your graph, adjacency matrix will be what? Adjacency matrix will be A, B, C, D. These four vertices or the nodes will be taken as your row number and column number. And this is an unweighted graph, but as the direction is there, so it is a directed graph. Okay. So what you will do? You can do that the nodes which are connected, you may put 1. So A is connected to B, put 1. A is connected to D, put 1. A is not connected to A. A is not connected to C, put 0. For B, it is connected to C only, not connected to B itself, not connected to A, not connected to D. For C, it will connect to D. So it is connected to D, so it will be 1. Rest C to 0, B to 0, B to 0. For D, it is connected to B only. Connected to means that detect the direction of the arrow. So this is the matrix. This is the adjacency matrix of one unweighted and undirected graph. Now, say these arrows are not there. Say this is just this. Then A, B, C, D, and this side A, B, C, D. The diagonal elements will be 0 because there is no loop. Loop means if it is started and ended in the same position. So that is not there. So A to B connected. Similarly, B to A will also considered as connected. A to C is connected. C to A will also be considered as connected if direction is not given. That means adjacency matrix means whatever the number of vertices, those many columns and those many rows will be there. And from that matrix, you can identify that which is adjacent to which matrix. Okay. This is very important in the regard that whenever we will try to use any kind of graph algorithm, we need the help. We need the help that to take the input or to do anything. We need to take the help of this adjacency matrix. Without the utility of this matrix, you can't do anything. Now, what about the list? List is nothing but your adjacency list. So adjacency list is nothing but your single linked list for each of the node. Single linked list for each of the node. And for each of the node, there it will keep one list. It will keep one list, and the nodes in the list will contain the address of the nodes which are adjacent to that particular node. So for this, what we will do, A, B, C, D. Four different lists will be there. A will be connected to B, B will be connected to C, C will be connected to D, D will be connected. This is your adjacency list. List of nodes will be header node, and for each node there will be separate single linked list for the nodes. Okay. So now this is the representation. Before we proceed to any algorithm, we must know what is the representation of the entire thing. For tree traversal, so we have learned that in order, pre-order, post-order, all those things are there. For graph traversal, we have two methods. One is breadth first search and another one is depth first search. Breadth first and depth first search. What it do? Now either it explore the nodes depth wise or it explore the node breadth wise. Either depth wise or breadth wise. Fine. So let us try to do it. How things are being done. Let me say the steps first. If I do BFS, which data structure will be required? Now Q will be required. Okay. How it's to be done? The starting node may be given to you. Take the starting node that may be given to you. Maybe you were also, you may be given the ending node also. Take starting node. Check its connected nodes. Insert into queue. Then delete the first element of the queue. Delete the first element of the queue and again insert its connected node. This way you will insert. When you will stop? Now when you have reached the destination. Now, whenever inserting any node, you need to maintain the origin of each inserted node. And then when you can reach the destination, you can stop there and do the backtrack. Fine. So let us do it now. Whether you will go for every time you will go and you will check continuously whether things are connected or not, it's advisable that you should start the entire procedure by starting with the adjacency list. You prepare the adjacency list first and then you can go forward. Okay, because if you have adjacency list, you can, it will take lesser time to solve. So first you prepare its adjacency lists. You have A to G, A, B, C, D, E, F, G. These many nodes are there. So you should start from there and prepare the adjacency list. Check the direction and prepare the adjacency list. A, from the A who is connected on here, from the B, A is connected, also G is connected. From the C, B and E. From the D, A and C. For the E, D, B. From the F, E, G. From the G, nothing is connected. From the G, nothing is connected. Okay. So now if I say C is starting point, A is ending point, how you can proceed? C starting point, C insert. What is the origin of C? No, nothing is origin. C is starting, so the origin of C will be considered as null. Next, what are the nodes are connected to C? B and E. Okay. Then, as it is a queue and their origin is C. Fine. What you are supposed to delete? The B. Means you have already deleted the C and you have inserted the B and D. Fine. For B and D, this is the, so You will keep here, but just move the pointer and you will find next your job is to delete the B. Okay. So if you go for the B, you people forget that you are in the class. Whatever your household discussions, you are not supposed to expose anything in the class. Anyway, the moment you will delete the B, you need to check what are the adjacent A and G, and A and G are already not C. Whenever you delete any node, you will add only those nodes which are not already taken. So if you delete the B, C, this is just for fragmenting we are writing here. Actually things are C is already deleted, then the B is already deleted. So B, C, E, C, just the symbol. Now for B, A and G will be there. For A and G, B will be the origin, that is the parent node. Okay. So, but I cannot directly jump to A. So the next deletion will occur with E. Okay. For E, it is D and B. Okay, so you can insert the D. B is already visited, so you will not write the B. Okay, next you pop out A and it will show you that you have reached the ending point. So A. Okay. So once you have reached the A, now you have to backtrack its root. What is the starting point? Must see. How you will backtrack? A. What is the parent of A? Now it's B. What is the parent of B? Now it's C. You need to find the path from C to A. So this is the path, this is the answer. Now you may say, why I do all these things? I can just check here and I can see the arrows are here and I can directly do. It's not about this very simple small graph. The algorithm stands for the very large graphs where you can apply this process.
backtracking টা আরেকবার বলবে?
Once you reach the destination, stop. Means the moment you can delete the destination, stop. Then check who is the parent of A? Na B. So take B. Then check who is the parent of B? Na C. And for C, no such origin, because C is the starting point. This way we are getting CBA. See this E, this point is actually not required. For the path, it's not required. It's A to B, then B to C, C to null or nothing. This is destination, parent of the destination, again parent of that node, parent of that node, this way. Okay. Is the procedure is clear? Is the procedure is clear?
Yes, ma'am.
Okay. Now, what is the benefit of this BFS and why it is called BFS and where we can use this for which type of problem? If you can look at this entire graph and all, how we are moving forward? Now, once you say visit C, this is the point C, what we are doing? Now, from the C, we are taking who are connected. Okay. So, from the C, B and D. B and D. Okay. From the C, it's B and E. Then you can go for B or C any. So you have started with B. Okay. Then you went for B and you have added A and G. But are you going this way? No. The next node that you will pop out, that is E. So E, once you go for E there is D and B, so you will just add the D. So you can see that it's not moving in this direction. It's moving root, means the starting point, then the next level entire, then it will come and then it will visit next level entire, then it will go for the next one. That means things are working in a breath-wise manner. So now, and how we are maintaining this breath-wise manner? Now with the help of Q. If I do not use Q, if I use any other data structure, then I cannot maintain this breath-wise manner. Okay. What it is? Here it's direct, simple, that enough. It is giving you the BFS algorithm. This is your BFS. So the BFS algorithm is giving you shortest path. Is giving you shortest path. So that means if you have any directed or undirected graph in which the edges are not having any kind of weights, but you need to find, for your problem definition, you need to find shortest path. That means you have to apply BFS algorithm for this. Okay. The maze means maze type of problem, where means some path and all those things which is forming the maze. Generally, we try to solve it either using the BFS or DFS after reading the statement, whatever we understand that which can be more appropriate, we apply that. These are the area, and this is the type of problem where we apply, and other than the simple graph problem directly. Okay, so this is all about the BFS. And if I consider the complexity, yes, it has to maintain this list, and also the more breadth increases, the space complexity will increase. The more branches it will have, the space complexity will increase that much. Okay. Next, we will do another algorithm that is called DFS. This is also another, and one more thing. In case of BFS, what we have done, that is BFS is one of the greedy approach. Why greedy? Now, whenever we are solving, now we are taking the connected. Here you have no other measure to check which is less distance or anything, but you are not going for all possible thing. You are taking one, keeping another, and go with the one thing. That way you have done. The way you have scanned it in a breathwise manner. Now, in case of DFS, what we will do? Again, let me take the graph first. Okay, so this is my sample graph and I want to perform the TFS. So again, the first job, that prepare its adjacency list. Otherwise, you cannot solve the problem properly. A is connected to B, is connected to D. B is connected to C, E, F. C that is connected to D. D that is connected to E. E that is connected to F. F that is connected to C, A. Yeah. So this is the thing. Now, in case of DFS, what data structure is being used? That is stack. What we check now? Reachability. Which one is reachable? Or you can say that we check the connectedness. Means connected means what? Connected means you are from one point to another point. If you can reach by any number of paths, then you can say that it is connected. But if it is not connected, if you cannot reach, that means it's not connected. So with the DFS algorithm, we can check whether from one node, other nodes are reachable or not, connected or not. Okay. That is the application area. For any situation, you check whether you can go there or not. Means you are inside a maze, whether you can go out or not. That is the thing. Means at certain position of the maze, and from there you can go out or not. If you need to find the shortest path, then BFS. If you need to just check that whether you can go from this point to that point or not, then BFS. Whether path exists or not. And BFS is path exists. To find the shortest path. So you need to think. Whenever the problem is given, you need to think and then apply. So now if I go with this one, so let us start. How I will start? Say I'm taking B as my point and I want to check which are the nodes are reachable from this. So in the stack, yes, you may start with by pushing null and all, but it it's okay. I'm starting with, you can start with that or directly B. So I'm starting with B. Okay. So the moment I insert it into the stack, the next step is pop out from the stack and push its adjacent elements. So what are the adjacent elements? C, E, and F. Now, you have to decide that at which side you will decide the top. Either the last element or this element. But ideally, if I say the pushing order, so this is basically first you have inserted B, you have popped it out, then you have inserted C, E, and F. So take the F. Okay. So next step, C will be there, E will be there, only the F will be popped out. Okay. So once the F will be pop out, what are the connected nodes for F? C and A. But C is already there, so you can take only the A. Okay. Now, then A will be removed. So it will be here. This will be C comma E. When A will be removed, it is BD. B is already visited node, so you will insert D. Okay. Then it will remove D. And once you remove D, D is connected to E, so you have nothing to insert. So it will be C comma E only. Then E will be removed as the top element. And F is to be inserted, but F is already visited node. F is already visited node, so you have nothing to insert. Then again, you have only C. You will remove C. So A, B, C, D, E, F. All the nodes you obtain from starting the point P. And all the nodes you are getting. So the nodes are, it means if you got these nodes by starting with P, you can say that yes, the graph is connected as the B. If I start from any point P, I can reach any of them. Okay. So for both the thing, you can take any two, say start with D, okay, and check whether you can reach or not. Start with D and check whether you can reach or not. And similarly, you find shortest path from C to A. From C to A, for this graph only, find shortest path, means do the BFS, and from the D, check the reachability. Or even if any graph is given to you, you need to check that whether the graph is connected or not. You need to do the same thing. You need to find that what are the nodes are connected to it, what are the nodes reachable. If from any point you find that all nodes are reachable, that means the graph is connected. So solve these two and tell me the answer. I'm waiting for your answer. Do it now. Done. What is the answer? I hope you have completed this. So what is the answer?
রিচেবিলিটি তো ইয়েস আসছে, আর সিম্পল ওটা সি ডি ই এফ এ হয়ে যাচ্ছে।
Reachability, yes, means you are getting all the nodes. Okay.
হুম।
And this is C, D,
ই এফ এ
E, F. So anyone else have done? Also, I need to solve it because this is a random graph. So anyone else who has completed can tell that whether this is shortest path or anything else can be, we can get anything else. Anyone else? All of you can unmute yourself and can give the answer. So let us do it because I understand there are people who do not want to use their time or they are busy in something else. So much important things are going on. So C is the starting point. Take the origin as null. From the C, the connected point is D. Then from the D, it's E. From the E, it's F. From the F, it's again C or the A. So it's A to F, A to F, F to E, E to D, T to C. Yes, no other solution is available as no other paths are there. Okay, fine. So this is where things are being done. How the problem will be given to you. It will be given to you as a, say, you need to as a matter of fact, the problems, as a matter of fact, the problem that is given, that is okay. So whenever you will be getting the problem, you need to use the proper matrix format. So what will be the matrix size? It will be n cross n. N is the number of nodes. So based on that, you have to take your input and then you need to take the input and then you move forward for these algorithms. Now you may say BFSDFAC is being done with adjacency list. That means I need to take the linked list. If you try with that, solving it using the linked list is very tough. Because in case of graph, there is no limitation that every node can have maximum 2 connections. That's not there. So it's not easy. Okay. Next, we'll do the spanning tree. Can anybody tell me what is spanning tree? I want to know what you know. I want some response from your side also, not the person who is every time responding. If you are in the class, you are supposed to respond. You are not studying this for first time. You have studied all these. So we can assume either all of you are very confident whenever you will get the opportunity, everyone will crack the Gensinex profile, digital profile, or something more and more and more. All of you are very much good and very much confident. Or else you are just not here. You are moving around anywhere, playing the game or anything else. Tell me, what is spanning tree? What may be the application of the spanning tree? I'm waiting for your response.
Recording in progress. Recording stopped.
Okay, actually, we are in means every day we are in the college. We do not have vacation due to JEE mains, and for JEE mains, jammers are on in some other building. I don't know. We are in the separate building, but suddenly this network error occurred, and that's why the connection gone. So sorry for the interruption, although that is not from my end, that is from Inter University, this B3 building where connection is also facing some issues. So let me go back. Now, if we are dealing with the spanning tree, if our entire graph is having n number of vertices, then the spanning tree that will be formed will also have n number of vertices. Okay. How many edges will be there? N minus 1. Why the word tree is used? The thing is that it should not contain any cycle. So it is tree. Okay. How many spanning trees are possible for a graph? It can be any number of spanning tree is possible. Among all the spanning tree, which can be considered as the most efficient one? The spanning tree. If the spanning tree is made of some weighted graph, that is edges are furnished with some weight, then addition of all those weight, which gives the minimum sum of weight, that is called MST or minimum spanning tree. Our job is not to find only the spanning tree. Our job is to find which one is minimum. Again, minimum, maximum, all these are basically optimization problem. And that is the gritty one. Okay. So if we go for this one, what we need to do? From a graph, we need to take all the nodes and the edges, connected those nodes, and the weight of those, all the edges, if I add up them, that should give a value which we will consider as minimum. Where we apply this? What kind of problem? Say, some road is there, road constructions are going on, some materials has to be used and all. You need to find that what is the, means if A to B is this cost, say A to B is this cost, via C is another cost, but maybe A to C then C to B value, means say this is 20 and this is 9 and 8. Then the path, the direct path 20 is more costly than this via path. So you need to find, means if I do for the spanning tree for this one, what will be? It will be A, C, B. Not A, B, C. Okay. Just for thing. So This way we have to decide. Now, obviously, we are not supposed to do all these in a just random way. Just we will look at the things and will do. Obviously, during programming, we are not supposed to see the private test cases and all. So what you need to do, you need to apply some algorithm. When? So when you will feel that you need to apply this, when as a whole, you need to touch upon different cities or different points, and you need to find that which path will give you the minimum thing, which path will give you the minimum thing. That is your target, that is your spanning tree. Means which has to cover all the points. That is also very much important. So Kruskal and Prim's, these two algorithms are there. What we will do with Kruskal? Let me take one graph first. These are the nodes. I'm taking it as a directed, not necessarily every time you will get everything as directed. So these are the weights. Okay. So the Kruskal algorithm says that first take all the edges with its corresponding weight and then short them. Then short them. Okay. As per their weight. Now, this is B2A. It's weight 5. It's A to C. You have two paths, A to D, sorry, A to D. You have two paths. Can write as of now both, but ultimately you have to, if parallel path exists, you need to take the minimum. So you will, obviously you will take this one, not this one. Oh, something is missing here, so it's 9. Okay. D2B is here. So it's 10. Then B2C again. Both path is there, although I will take 7 only, but as of now you may write this as 10. Now, what are the minimum? Among all these weight, you can check that 4 is minimum. Okay, 4 is minimum. Take this one, A, can use straight line also. So it's about how you are connecting the nodes only. So you can use straight line also instead of this curved line, the parallel path. Take this. Next, 2, 5 is available, although this is parallel to this, so you cannot take this. This is parallel to this, so you cannot take this. So next minimum is this 5. Fine. Next minimum is 7. B to C. Next minimum 7. Next minimum is C to D. But I cannot take C to D as it will make a closed cycle. I cannot make C to D as it is a closed cycle now. But again, it's a directed graph. If it is an undirected graph, then if I take C, D, then that would be problem. But now if I take it's D to C, it's D to C or C to D. I need to check this. If it is C to D, that is with 8. So if I now take this one, this, or even another one, as this direction is this one, it's not making a closed one. It says that you can go to B to A, then A to D, then this side or that side. So you can take the direction for a directional part. If it is directed, then you need to check more carefully that whether it will make it cyclic or not. If it is cyclic, you are not supposed to take. If it is not cyclic, you can take it. You can take it. If it is not making any kind of closed cycle, you can take it. And as long as, and another important thing, that this way, should I continue? First point that I have asked, that next minimum weight is this, should I take it or not? One point agenda is, first point, that whether it is making a cycle or not. So as it is a directed graph, you need to think that what is the direction. Direction wise means if something is in this direction continuously, then it is cycle. But if it is, say, then it is not. It is not making cycle. But should I take even this one? Should I take even this one? The answer is no. Why? Because I already get all the nodes. So the moment I get all the nodes, I can stop. The moments I can get all the nodes, I can stop. I can stop. That. And again, that is true for undirected. But if it is a spanning tree, and this is the situation that you can go from B to A, can go from B to C, but you cannot go for D to A or something, then you can still continue, but it will show that there is different cycle. Fine. So that means you can take this one. You can take this one. Although all the nodes are already being taken. And if you consider the directions only, that means B to A is possible, A to B, going to B to A is possible, but going from A to B, it's not possible. Similarly, B to C is possible. This line is not C to B. So based on the directions and all, If it is making cycle, you can stop, and not only stop, but you will continue till you are reaching all the points. Now, even if I take this C to D, this will be your 8. Is it making cycle? This is what? B to C, 1, C to D, 1. But this is no. This side, A, that is also not. This side, the direction is this. So it is making in this way. All the directions are not in the same way. So it's not making cycle. Fine. But another thing is, should be there, that there must be a way from reaching one point to another point also. Spanning tree is involving all the nodes and all. So once it get all the nodes, you may stop there. But if it is directed, you have to think about the direction. But if it is not directed, forget about the directions. Then whatever is minimum, that is A to D, if it is not directed, then things will be pretty much easier. It will be 4 here. If you go for something else, that is after 4, there is the next minimum value is your 5. You can go here. After that, what is the next minimum value? Obviously, will not take this one because it is already taken. Next is B to C. You will take this and you will stop here. You will get this and you will stop here. Okay. So you have to maintain everything, but if it is undirected weighted graph, things will be much more easier than the directed graph. Yes, because actually it will not make cycle. If directions are in different way, that means that is not logically, it's not making any cycle. The starting point and ending point. Cycle means what? Cycle means if starting point and ending point become same, then I'm considering that that's a cycle. If that is not, then I can say that, okay, if starting point and ending point, see, from here, I'm starting from this point and from this point, again, I'm going this way. Is it cycle? Means if I take half from this side and another from this side, it's not cycle, right? You cannot use in this direction, or you cannot use this direction. So if directed graph, then making up cycle, that is very much critical thing. Checking whether it is making the cycle or not, that is very much critical thing. Generally, it comes with undirected one, because no one will ask you that write a program to find the minimum spanning tree. But people will write that you will get the problem. There are certain nodes, certain paths or the distance, those things will be given. You need to find one mapping which will give you the minimum cost path. Means say this type of things will be given to you. Find the minimum spanning tree. Find MST using the Kruskal algorithm. Do this. Tell me the graph and the answer. do this.
ম্যাম একটা এজ বোধহয় লেটার মার্ক করা নেই।
কোন এজ নেই? আচ্ছা, ও
ওই যে এ
হ্যাঁ,
থেকে
হ্যাঁ,
বি এর
হ্যাঁ,
মার্ক।
mark, হুম। I hope it's done because I'm not getting any answer for quite long time. But
24
maybe you just take all the, if you have done the right addition, everything, this will be AE, which is 6, AG, which is 5, GC, that is 5, CD, 9, CF, 4, ED, 3, FB, 7, FD, 8, and BD, 8. This is your, I hope I have taken all the lines, I hope so. So if you have taken all, then what is the minimum? Minimum is first is this. So if I take this, this would be A, D with 3. Next minimum is 4, that is C, F. You may draw it in a crossover mode, or you may write it in this way, C, means F and C in this way also, that is your choice. Because actually, if I consider that there is a path exists, then it will be actually in this way also. So 4. Next minimum is 2 5s are there, any of the 5. So you can take, say this, AG, 5 is there. Then if I want to take next 5, should I take the next 5? Should I take this one? Should I take this one? Should I
ম্যাম
take?
একটা তো অলরেডি কনসিডার করে ফেলেছি তো আরেকবার
And that's why I cannot take. Should I take this one or not? There is no such thing that if you have taken 1 5, you cannot take the another 5. You can take, you can. They are not making any cycle, so you can take it. Can take it. And then which one is minimum? Na E. Oh, sorry, এটা E তো নয়। কি যা হোক আমি তো F বলে পরে লিখেছি, সুতরাং anything E or F, whatever you want to take. Can I take this one? Yes. This one also. Let me check. It will make A, C, F, E. So you cannot take this one. You cannot take this particular line, because if you look at the graph, it will make the entire cycle. So it's not supposed to be taken. Okay. So next minimum is 7. F to B. F to B. Can take it. That is 7 with this. So A, B, C, D, F, G. All the nodes are taken. So you can add up 3 plus 4 plus 5 plus 5 plus 7. This can be, means if I didn't have done any mistake in selecting or anything, this can be the answer. Okay. So this is how the Kruskal works, taking the lines one by one, edges one by one, until it covers all the nodes and it's not making any cycle. Now, I have one question for you, that is, I have discussed how things has to be solved, but if you need to do with, with the program, how you will do this? The graph can be given to you as a matrix only. So how you can manage to do the program? What is your opinion? Because that is very important. You need to use the Kruskal in different problem solving. So how you can manage that? How you can manage that? How you can implement this in a normal program? The graph is given as your input, as a matrix input, adjacency matrix. How you can manage this? Think something and tell. I don't understand that why you are in the meeting. If you are not giving any answer, if you have decided that you will not respond, I'm just asking that, okay, do one thing. The first job is, as of now, do one thing. I'm giving here one graph. You take the input and just come with the answer for all the ages, all the ages value. Take this graph as your input and tell me, means whether you are able to say here another path, parallel path. If parallel path exists, you should print only the minimum. This much. Just take this graph as input and tell me that what is the output. You need to output. If you cannot give the age name, you instead of AB, if you want, you can take 1, 2, 3, 4. That is also okay. You just give me output of all the ages. Do it now. Use any programming language of your choice and give the output of all the age values. That is the cost. Because if you cannot do it, it's not possible to apply all these things in your graph. Just not possible. Because graph is such a chapter, you will get different kind of problems from there. But for that, at least you need to take all these. Or you can take just the unweighted graph, A, B, C, D. apply DFS and BFS. Do it now, because otherwise whatever I am telling, everything will go vain, that if you don't know how to take the input. Do it now. At least think and suggest me that how we will proceed. If you cannot do it now, do it later, but at least suggest me how we should proceed. Suggest. তোদের কি ব্যাপার বলতো? সকালে ঘুম থেকে উঠে খালি জুমটা চালিয়ে নিচ্ছিস, কিছুই ভাবছিস না, কিছুই বলছিস না। তোদেরকে তো গ্রাফের প্রবলেম আসবে, রিক্রুটমেন্ট ড্রাইভে তো গ্রাফের প্রবলেম আসবে। অ্যালগোরিদমের ইমপ্লিমেন্টেশন বা প্রসিডিওরটা তো ম্যাথমেটিক্যাল ডিসকাশন, কিন্তু করতে তো তোদেরকেই হবে। বল এইগুলো ইনপুট কিভাবে হবে, কিভাবে নিবি ইনপুট গুলো? করেছিস তো, এখানে তো ম্যাক্সিমাম কম্পিউটার সায়েন্সের লোকজনই আছিস। তোরা তো অ্যালগোরিদম ল্যাবও করে এসছিস, ডেটা স্ট্রাকচার ল্যাবও করে এসছিস, ডেটা স্ট্রাকচারে না করে থাকলেও অ্যালগোরিদম ল্যাবে তো এগুলো করেছিস। কিছু তো বল, নাকি আমার কোনো কথাই কেউ শুনতে পাচ্ছিস না? আমি একাই মিটিং এ কথা বলছি, আমি তো বুঝতেই পাচ্ছি না। আমি কি একাই আছি মিটিং এ? তোরা কি আছিস? তোরা কি আছিস?
আসলে ম্যাম ওই ডিএফএস আর বিএফএস এর মানে ডিরেকশন দিয়ে করেছিলাম, যে এখানে তো মানে নন ডিরেক্টেড, সেগুলো বুঝতে পারছি না।
ডিরেক্টেড আনডিরেক্টেড কি আছে? তোর তো একটা জাস্ট সিম্পল গ্রাফ দেয়া থাকছে, তোকে একটা কিছু বের করতে হবে, একটা পাথ বের করতে হবে। আনডিরেক্টেড মানে তো সে দুদিকেই যেতে পারে। মানে আমার অ্যাডজাসেন্সি ম্যাট্রিক্স যদি ধর এ আর বি দুটো নোডের ক্ষেত্রেই আমি দেখি, তো ডায়াগোনালি তো সব সময় জিরোই হবে, কারণ আমার এগুলোতে তো লুপ নেই। আমরা এমনিতেও যে কোনো গ্রাফে যখনই আমরা প্রবলেম সলভ করার চেষ্টা করি, at any time even if any loop exists, first job is remove that particular loop and the parallel path. If any problem exists, that is I was discussing even in the Kruskal, that if parallel path exists, even if you record, but ultimately you have to discard one of them. So which you will discard, which is having maximum. So this one will be A, B will be 1 as well as B will be 1. First you need to give, you cannot draw anything, you can give just the adjacency matrix. So A is connected to B, so as well as B is connected to A. So both will be 1. Again, if it is A, B, C, for C also A is connected to C, C is connected to A. Whether B is connected to C? No, B is not connected to C. This will be this. Fine. C is connected to B. No, this is not here. So this will be 0. This way you have to make the entire adjacency matrix. But if you go for this one, this will be with your, from the parallel path, only one will be there. So A, B, C, D. This side, it is also A, B, C, D. The diagonal will be 0 as 0, or if you may you may give based on the problem statement, sometimes we give very large value, say positive large value this way, or negative large value this way. Depending upon your requirement, you can use the diagonal. Okay. But in normally, when we mathematically solve, we just put it as 0, or sometimes it's, if it is required that I need to find the minimum and all the things, sometimes we give the infinity, but normally we give the 0 for the diagonal. But if it demands something else, we will give. So A to B, that is 5. B to A, that is also 5. A to C, that is 3. A to D, is there any connection? No. So as no connection is, direct connection is there, you may put infinity, that is very large value. You cannot put during the programming input, you cannot give a graph representation infinity. So you can give a very large value like this. Okay. B to B, that is 0, fine. B to C, B to C is 4 is there, put there. B to D, 5 is there, put there. Then same thing, C to C to A, that is 3. C to B, that is 4. C to D, 6 and 7 available, but I will take only the minimum value. Same for similarly, you should write for the D. Now, this way, I am not completing it. You just need to complete first the adjacency matrix. Okay. So if something is not connected at all, direct path, you may take in this way, diagonal as 0, this way. How you will take all the edges? First of all, whenever you are taking this, you have already taken this 6, 7 is already discarded. So that means now you have inputted this one, A to B, A to C, this 4, this 6, this 5, A, B, C, D, right? Now you what to do? I'm telling you that keep me, say you can do the sorting letter. You can give me, I am asking you that, okay, give me the ages value. Give me the ages value. Now, if you want that, you will print all the values which are present here in the matrix. What will happen? Now you will print, as it is an undirected graph, you will print 2 for this line, 2, 5 for this line, 2, 3 for this line, 2, 4 for this line, 2, 6. That means it's not easy. So what you need to do? You need to check for each I and j, you need to keep a record which node, that is which I or which j, whatever that is your choice, you have already visited. Say if you have started with I equals to 0 and you are getting the non-zero value at B and C, non-zero value at B and C. Now you say it is very large, this kind of, you may put another checking also. So if you get B and C value for j equals to, this is 0, 1, 2, 3, 0, 1, 2, 3. So you just j equals to 1, you are getting one value. J equals to 2, one value. That means from the A, the B and C already done. So if it is done, then you are not supposed to visit what? You are not supposed to visit I equals to 1, j equals to 0, and I equals to 2, j equals to 0. You are not supposed to visit, right? So you can keep the track this way. Okay. Similarly, for every row, for B, you are not supposed to visit the j equals to 0 because all the connections that is with B with A, that is done. So you are supposed to deal with rest of the things. So first column you no need to visit, second one is B to B, you no need to, and you are not supposed to visit when I equals to j also. Then you go for the C and D. Again, the new j values that you are taking, crossover, that is whatever the connection with C, B to C and B to D, if you got already, then you no need to visit those rows and columns, that particular positions again. So you have to implement it in that way. Means if I want only to get all these values. Okay. If I want to implement this Kruskal algorithms and all, what I am supposed to do? First job is what? First job is I have to take the individual edges value. So this way, every time you are getting a value, you put them in a single array, okay? And sort them, After that, once your array preparation is done, means edge, noting down of edges are done, then you should sort them. Once you sort them, what you will get? Now, ascending list, then you take each and every point and check its I and j position. Check its I and j position. Okay. Or if you don't want to sort, then also you can do that every time you find the minimum value. Every time you find the minimum value and check its ij value with the previous one where you are keeping the records, which node is already visited or not. With I and j, you need to check and you need to proceed that whether you have visited the node or not. Means for a particular age, say this 5, what are the connecting points? Now this is your 1 point, that is this and this. So for this particular, from this I and j value, you know that what is which age or anything. So from there, if some node is already visited, you are not supposed to visit that node. You can keep the track with I and j, the way I have taken all these things, and then You can every time you can find the minimum and check whether it is making a cycle or not. Again, for this, that also you need to check the same ij value. You just think properly, then you can only do. Otherwise, cannot do. Yes, we'll discuss disjoint set, how you can use all these things, but unless until you think yourself, it's not possible. Now can you do this? Now can you do this? Just take the graph as a matrix input and print the age values. Not in a double format, as a single format. Just try that. Are you doing this? Are you people doing this?
Yes, ma'am, trying.
Try this. If you want, you can, as you know, the Python also, you can use that set concept, then also you can do. For set never allow to repeat the values or anything which, or if you want to use any other language also where the repetition is not allowed. That way you can do. Okay, so not getting any response, but better you try. Otherwise, next day I'll show that how you can do all these things. But you can try because many resources are available. Even you cannot do now, but you remember you have to do this. You have to learn that how to take the input of the graph, how to perform the traversal, or finding all these, which node is visited, which is node is not visited. You have to do that sort of coding during your placement coding section. So multiple n number of resources are available. You know how to solve it mathematically and what will be the result. So solve the graph first, then you understand the program, right, and check whether the answer is correct or not. Fine. It is the thing that you need to learn and you need to do. Otherwise, only other than the means, I hope that some of you are very well prepared who have practiced a lot, the FT, the codings and all, they maybe already have gone through. Or the thing is, many of you may got the opportunity after the first preliminary test, you may got the opportunity to appear in the digital or that Gensinex profile. You will get some time and then you will get the opportunity to sit for a retest for that purpose. And those things are based on the starting point of those things start with all these graph, okay, or the greedy dynamic based problems, okay. And under the greedy, most of the things are this graph kind of things are there. So please do that practice. And if you don't understand some coding, why it is done, what it is, first do give your full effort to understand, then you ask. It's not for a single line, why this is, why this is. You are not in a class 1, class 3. Within next few months, you have to go to the industry and you need to solve your problem by you. I have all the codings, but I am not sharing with you at this moment because I want that you should learn this. Otherwise, no use of investing time from your side. Forget about our side. So this is one algorithm. I'm asking you that you apply the Prim's. Prim's algorithm is another algorithm for finding the shortest path. So you can, for Prim's or Kruskal, in Kruskal you are supposed to start with all minimum weighted edge, but for Prim's no such thing is there. So what you need to do, you can start from any point. Say you will starting from A, okay. Now from the A, which are the edges connected? B, C, D. This is 5, this is 5, this is 4. So which one is minimum? Now that is D. Now in the next step, in the Kruskal, what we have done? In the Kruskal, the next minimum edge we have taken. But in the Prims, what you need to take? For A and D, whatever the connections are there, which one is minimum, we will take this. So from the A, my connections are 5, 4 and 5. I have taken the 4 already. Now for the D, it's 4, that is to A, which is already taken, 6 to the C and 3 to the B. So if I compare all, then I am getting that this connection is minimum weight. So take this one. Now, so next you have taken this one. First you have taken this, second you have taken this. These two are already taken, so you are not supposed to take it again. Now you need to check which connection is minimum among all the connection that started with A, D and B. So for the B, 3, that is already taken. B to C, that is 4. Okay. A to C, that is 5. A to B, that is 5. But you cannot take this as it will make cycle. D to C you can take, but that is so. From remaining weight, the minimum weight is C, that is 4. So A, B, C, D, all 4 nodes are being covered. So this is the weight, this is your minimum spanning tree, and the weight is 4 plus 3 plus 4. This is the result of this is the weight of the minimum spanning tree if I use the Prim's algorithm. Now, if I need to do using the program, how I need to do? First, I need to take the adjacency matrix properly. Then for each row, say you start from like this, you start from A. So A, B, C, D, all the elements are there. You will find which one is the minimum in that row. Take that one. Good. Now, whatever you have taken the as in which column you got the minimum, next you move to that row. Fine. Say you got minimum in the D column. That happened here. So in the next iteration, you need to find the minimum in between A and D, provided that that row, that column value is not visited yet. Okay. So if not, then you will find. Means first find the minimum among both the rows value and then check whether it is already visited. Not visited, then check, and also you need to check that whether things are going to same area or not, means same point or not in any case. So this way you need to do. For the next time, say for this one, you will get it here B. So next time you need to find the minimum in A, B, D. This way you need to continue. Fine. So these are the things today. I will not discuss the shortest path and all, because under the shortest path 3 big algorithms are there. And some specific problems of algorithm like traveling salesman or sum of subsets or the string matching, string related problem. I'll try to discuss in next day only. I'll try to discuss that. So this much, if you have any query, you may ask, but I request you, if you want to succeed in this software domain, you need to learn to code all these things. Right? You need to learn how you can deal with the graph. You have to practice, you have to understand, you have to debug your own code. You have ample of resources. You search, you will get. You know how to solve it mathematically. So you can check the code, what is given there is correct or not. Understand that. If you do it in this way, you will get the reward for your efforts. But if you do not do, it will be limited to initially this pattern and all. And you cannot excel, not at the beginning, even at the later. Okay. So thank you. If you have any query, you may ask. Otherwise, you go for break. If you do not have any query, you can leave. If you do not have any query, you can leave. If you have any query, you leave, or you go practice. Then if you are in a stage of some query, you may ask also.